us about an interesting paper that he found. The title is Foot and Ball, Integrated Players and Ball Detector. So we are now talking today about video recognition and, video recognition in a very challenging environment, which is sport and soccer in particular. Here we're going to have, essentially two entities to track, players and ball. And Daniele is going to tell us a little bit more about why he picked this paper, what are the novel aspects, and what are the benefits of this new approach. Please, Daniele, go ahead.
Yes, I will share my screen. Okay, you should see now.
Mm-hmm.
Okay, so why this paper? This paper describes a detector for ball and players detection and, as they say, in high resolution long shot video. This detector produces, as you can see from the video, a ball confidence. This picture, a ball confidence map that encodes the position of the ball, and also a player confidence map and the player's bounding box. But why we are interested in this paper? The network used in this paper used the feature parameter network, where lower level feature with higher spatial resolution are combined with higher level feature with smaller spatial resolution. This improves detection of small object, for example, the ball in our case, because larger visual context around the object of interest, that in our case is the ball, is taken into account. Now, as we can see from the architecture, the input image is processed bottom up, like usual, by 5 convolutional layers. And we produce feature maps with decreasing spatial resolution and, of course, increasing the number of channels. The feature maps are then processed in a top-down direction. And this is the interesting part, because the spatial resolution of the feature map from the higher level is upsampled, as we can see from the chuper up in the picture, and then is added to the feature map from the lower level.
Okay, hang on. Do we have any questions, Federica and Giacomo, about this architecture? I have one, but maybe you can think about others.
Yeah, thank you. Yeah.
So you're saying lower level and higher level features. What you're talking about, Daniele, here is just feature that are sampled or extracted by different levels in the deep convolutional network, right? It's always the same kind of features. It's just that they are extracted at different, sure. Layer, exactly. A different layer, right?
Yeah, sure. And the idea is that, of course, at the beginning, we go in depth inside the neural network, but then after we consider also more than just the last level of the convolution to decide the classification. And the main idea is that we will sum the feature map from the higher level, of course upsampled because of the spatial reduction that we have done, and then we sum using a one per one convolutional block, because we have to adapt the input channel, the channel dimension. Okay,
all right, thank you.
We have a couple of questions maybe. So the first one is like, you want to create some bounding boxes around player, is that right? Okay.
Yeah.
So why in some sense are you reinventing the wheel and not using, I don't know, some off-the-shelf method like, I don't know, YOLO or whatever you prefer? So why are you doing that like from scratches?
Okay, yeah, the idea behind this paper is that, as we will see from the result at the end, is that they wanted to try to minimize the number of parameters. Okay, so they compared between different approach in the state of the art, And they, with this type of architecture, they minimize the number of parameters, and so you can see the number of FPS that are very higher than, for example, a faster RCNN. So
zoom in, please.
Oh, sorry. Yeah.
So basically, you are telling me that they are doing some sort of lightweight model, specifically tailored to, I don't know, football in this case. So player recognition.
Yeah, this is the main idea of the paper.
Okay, I see.
And in terms of performance, are we paying a price or not?
Okay, the performance, as we can see, are very good. Because there are, of course, you can see also the difference between the standard approach and where they put no top-down, and the top-down approach that is the one that use feature pyramid network. And yeah, the results are quite good for the ball, not so much better for the player, but still we have higher value for FPS. So it's nice because they are comparable, but still it's faster.
Okay. Any further questions, guys?
So these two are two data sets, right? The one on the top here, the soccer player and ISS, I see. And do you think that the same architecture could be used for other sports as well? Or like, I don't know, YOLO would put a generic ball for tracking, or, you know, person. So in this case, what happens if I'm tracking a tennis ball or rugby or whatever? Do you know if the algorithm still works up to some point at least?
Not sure, but they tried only with football actually. Of course, there are some sports that are comparable in some way. So also for the visual, the point of view of the camera. What we have to say is that in this case, they use a fixed camera with long shot view. Okay, so actually the ball is very small. So yeah, it's comparable also in some other sport in which the ball is very small, but not sure.
So this type of camera is something that you will have in a like professional game, something like that. So if I'm watching a game on TV, would the camera be more or less the same? I mean, I guess I can tell from this video you are showing me that the answer is probably, well, I don't know.
Yeah, difficult to say because usually we have more point of view during the match. But this is one.
But I mean, this one seems very close to the box actually. So yeah, it doesn't, because usually the camera would be like sort of around the midfield, right? And then you would turn right and left. Yeah. This one seems very much on the left, let's say. So probably it's slightly different. Okay.
Yeah, I saw also some other video of the dataset in which they trained the network, and actually they have also different point of view also in the middle of the field, also on the right. So yeah, this is just an example, but they have also a different point of view.
Right. Yeah, and perhaps just the last question, and I'll let you finish. So like from the architecture that you were showing us a little bit before, I mean, it doesn't seem anything like new. I mean, they're using some convolutional layers, and yeah, I mean, a combination of convolutional layers. Are they using something very peculiar to this case? Like, I don't know, is this architecture peculiar in any way, I would ask? I mean, up to the thing that you were mentioning before, so combining low features and high features.
I don't think so. I mean, it's very straightforward. The only interesting things is that this combination, okay, from a low-level feature, high-level feature, and in some way we know that information from first layer are of course necessary for spatial location of the object. but then they also combine with other layer information, and as we can see from the results, actually they improve performance. So it was very interesting for me.
Cool.
Yeah.
Anything else, guys? Because we're almost out of time. Yeah.
I would like to ask, but it's my curiosity, why with this combination of high-level features and low-level features, we can, for example, classify where the ball is, while for players, we just need the high-level features. If it's written in the paper, I don't know, but they use, it seems like they're using only high-level features for the player classification, and then instead for ball classification they're using this top-down method. And it's interesting for me that to see the ball you need to have a combination of feature, while for the players you only need the higher part. I don't know.
Yeah, I think that it's because the ball is a very small object in the field, and in some way it's more difficult to detect the ball than actually the players. So probably they didn't need something more for the player, because also in state of the art it's quite usual to have a good result for player detection. Probably the point of the paper is more on the ball, okay? So it's a difficult task, and then they found out these new techniques, but I think this is the main reason.
All right, guys, I don't know if Daniele, you want to add something. We really literally have 30 seconds, otherwise we can wrap up.
No, I think I finished. Yeah.
Okay. Well, listen, guys, thanks a lot. So all the details are going to be available in the description of today's episode. And well, thank you, Daniele, to moderate and curate this interesting paper description. Thanks to everybody for participating, and I'll see you in the next episode. It will be about what is going to be the next episode. It's going to be Federica, right?
Yes, it's about defect detection and localization in manufacturing. I'm sorry.
Awesome. And we say hi to Ade, Federica's dog. You should bring it over sometimes.
You hear it.
He's probably smarter than an average intern, your dog.
No, I don't think so.
Anyway, thank you very much. Bye-bye.